So chemical nomenclature. Chemical nomenclature, just for the basics of it, is how we're going to be identifying what chemical is what. Because writing down just like CH3OCH2 is going to be, it's going to be difficult, and sometimes you might miss a letter or a number in there. So this is what we have chemical nomenclature for. This is how we go about naming those chemical compounds to sound all official and fancy. So all this, so they're used to represent the particles of an element or compound in written form. There is two different ways that we go about chemical nomenclature. We have the non-organic chemical nomenclature and we have the organic chemical nomenclature. I believe that we're going to be going over the non-organic chemical nomenclature first. Okay. So a lot of the elements exist as single atom particles, like helium, lithium, pretty much any of the elements usually exist by themselves, except you sometimes have your diatomics, which are the two atom molecules. Can anyone tell me what our diatomics are?
Like the O2, H.
Okay. So we got oxygen, got H, which is hydrogen.
Something about beer.
Mm-hmm.
Fluorine.
Okay, fluorine.
Chlorine.
Yeah, chlorine.
Have no fear of ice cold beer.
That one.
Yeah, beer. So B. There's two chemicals or two elements on the periodic table that are going to start with B. We have like boron, we have beryllium, we have bromine. So which one of those do you think we're going to?
Is it boron?
It's not boron.
Bromine?
Yeah, bromine. So a lot of the ones in the 17th column, I think they're the halogens, are going to be diatomic. So we get a nice little periodic table of it. So we got hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are your diatomic elements. So when they are by themselves, so just hydrogen or just nitrogen, we want to write them as H2, N2, O2, etc., because that's how they will exist as a stable element. Whereas we could take like neon or magnesium, and if it's by itself, it's just going to be a single atom. So it's just going to be Ne, no subscript necessary. From Christina and Edgar, we got Cl2, same with Salvador. So yeah, so Cl2 is going to be chlorine because it's diatomic. From Edgar, we got argon as Ar, so we get got a single one. Bromine, it's going to be Br2. Then what about krypton? Kr. So yeah, krypton's not one of the diatomics, so we're just going to be writing it as Kr. Get these. So that's how we're going to be writing just like elements. And so if you see Cl2, you don't have to call it like dichlorine or anything like that. It's just going to be chlorine. If we see Ar, it's going to be argon. Okay. This is a breakdown of your periodic tables. That's just where the metals, nonmetals, and metalloids are. Okay. So now we're going to get into determining how many of like a certain element is in a compound when we're not actually writing the compound how we've been doing it. So if we're talking about like water, H2O is just called water. It doesn't need a fancy name. We don't need to say there's 2 hydrogens, 1 oxygen, because it's one of the most common things that we have. And same with ammonia. And I can guarantee that this bottom bullet point, there will be a question like this on the rest of your test, most likely, that it'll say, what's the breakdown, or what's this element called? And he'll just show you H2O. And the proper name for it is water. There's a scientific name, but why use a scientific name if everyone knows that it's going to be water represents H2O? Okay, but then we get into the binary molecule compounds. And the first word is that the element appears in the chemical formula. So let me see if I can pull up an example. Let's do. Okay. So if I have, let's say, magnesium. For if everyone has their periodic tables, what column is magnesium in?
2.
2. Okay. Thank you. Just me not having a periodic table. So, group, yeah, but columns are better for me because, so here we have magnesium, or Mg, and Cl2. So it's called a binary molecule because there's only 2 different elements or 2 different things. We can also have binary molecules with your polyatomic ions, but we'll get into that a bit later. But for right now, we have 2 different elements. So binary means 2. So the first word is just the element that appears first in the chemical formula. So we get Mg here, which is magnesium. So when we're writing out our nomenclature for this, we can just write magnesium. Then the second word, we'll go over prefixes later, but the second word is going to be the one that appears after the first, hence second. And we're going to throw on the suffix of ide, IDE. So we have chlorine. Instead of chlorine, we're going to put chloride. So we get magnesium chloride. And this is all you have to do for your nomenclature that has a metal and a non-metal. So magnesium is a metal, chlorine is non-metal. And it should specify non-transitional metals. So the first 2 groups, or the first 2 columns. So group 1, group 2. We don't have to do anything special. We just have to put the name. So just magnesium.
Cole, when it says that the prefix denotes the number of atoms in the molecule, would it be like magnesium, like dichloride or bichloride? Like how does
so I'll get into that right now. But for a non-transitional metal plus a non-metal, this is all you have to do. You just need to remember the suffix.
Okay.
But if we get into things like, I should just pull up periodic table so I can make up compounds. That's where the degrees come in that Dr. Henry has. He has all that memorized.
So Cole, because while you're looking at that, so I versus 8. When do you use 8 versus I?
That is part of your polyatomic ions, right? If you have all those, you have like sulfite, sulfide, all those weird ones. But for this, we're only going to be using the IDE if it's just a normal compound like this, because that IDE just represents the end of the compound. But we do get those polyatomics like sulfite or sulfate, and those suffixes aren't talking about the end of the compound. Those are actually talking about how many oxygens are in the compound. So they represent something else that's not talking about normal nomenclature.
Can NO3 be an example of that?
NO3?
Yeah.
Sure. So is that polyatomic, or is that just a random compound?
It's nitrate.
Yeah, it's nitrite. So
but it says nitrate.
Or yeah, nitrate. So we'll get into that because you're gonna want to know your normal nomenclature before we get into polyatomics and how those function. But so I'll just do, I don't know, S2. So get S2Cl5. So these are when we have a covalent bond, aka a nonmetal and a nonmetal. This is when this prefix rule comes in to play. And the prefix is just indicating the number of atoms in for each of the elements. So we can actually just start off with, this is how I learned it. We just start off with just saying sulfur. We're going to identify what elements are in this compound. We have sulfur represented by S and chlorine represented by the Cl. And how many sulfurs do I have?
2.
2. So the prefix for 2, which I'll show you all the prefix is di. Di, not as in you're gonna die. So we get disulfur. And how many chlorines do you have?
5.
5. So you're going to put the prefix for 5, which is penta. So this is going to be a throwback to your geometry back in elementary. Number of sides a shape has. It's going to be penta. So we get disulfur pentachlorine. The issue with this is we'll never know when the end of the compound occurs. So that's when we're going to take the last element in our compound, which is chlorine. We're going to scratch off their suffix, the ion E, and we'll add our suffix, the IDE. So we get disulfur pentachloride. And a question I had when I took this class is, how do I know where to put the IDE? Why did I put it after the R in chlorine? Why didn't I put it after the O? Because we get like oxygen. Oxygen isn't changed to oxygenide. It's changed to oxide. We drop more than half the word. And I'm sure Dr. Henry has come up with a better answer than he gave me, but it's really, you just feel it out. If it doesn't sound right, it's probably not right. But he's not going to dock you off for spelling 95% of the time. So you don't have to worry about how you spell the words, as long as you have that IDE and it looks like it's in the right location. He might tell you something different, but that's what I'm going to go with. So get the first element, the prefix, which I'll show you a list of them, tells you how many of the atoms Then the second word is just the second element. So here are your 10 prefixes that you need to know. You should have these memorized because they'll also help in the organic nomenclature later on. But if any of you went to like a bougie high school that taught like Latin or Greek or those weird languages, these might seem familiar. If you didn't go to a bougie high school that had that, like me, these are just representing like the shapes of geometry. So yeah, like pentagons, hexagons. We don't see 7-sided shapes very often, but we get octagons, stuff like that. So I would write these down or download the PowerPoint, copy it from that. So we get these and we can apply them to a bunch of formulas. So in the chat, or if you want to annotate on my screen, let's write a formula or a name for this, for all of these. So we got dinitrogen pentasulfide, we have dinitrogen pentaoxide, then we got I409, then PF5. Edgar put his answers for the first two as first one was N2S5 was what he put. N2O5. For the second one. Any guesses for the last two?
Are you talking about for the I409?
Yeah. So do you want to try to name that?
I would like to try, but you need to put on the last screen with all the prefixes.
Okay. So
It's Nuna oxide.
It's tetra.
Okay,
okay.
yeah. Tetra,
So tetra is 4.
tetraiodine nona oxide.
Yeah.
Oh snap!
So tetra means 4. So there's 4 of the iodines. So tetraiodine. Then we get, there's 9 oxygens. So nona oxide. And that IDE represents that it's the end of the chemical compound.
And that's only when it's either 2 nonmetals or a metal and a nonmetal.
So that's for covalent bonds. So for a for a nonmetal and nonmetal.
Okay.
Yeah. For
Last one would be phosphorus pentafluoride.
yeah, it's just phosphorus pentafluoride. Because there's it really depends. So when we only have one atom, we have the word mono, which means 1. But 9 times out of 10 we just don't use it, because obviously if we're saying that the chemical is in there, there's at least one of them. And if we say di, then we know that it's not just 1, it's 2. So you'll see them when they do but mono. And what I picked up from taking this class is that it's really the common chemicals that we deal with a lot is when we start to use mono. So we get carbon dioxide, so CO2, but we also have carbon monoxide with that mono, denoting that there's 1 oxygen. And that's just because their CO and CO2 are very common chemicals that we deal with. So you kind of need to be specific on which ones. So get our solutions. N2S5, N2O5, tetraiodine monoxide, then phosphorus pentafluoride. Okay. So that's all it is for covalent bonds. For so nonmetals plus nonmetals. That's all you have to do. You just need to know your Greek prefixes and tell me how many of the elements are in the compound. Okay, then we get into ions. So this is going to be with more metals than just covalent bonds. So for a monoatomic ion, we get ions formed with a single atom. So we all know what an ion is. It's just a element that has a charge to it, because elements in their normal state should be neutrally charged. Then we get a cation, which is positively charged, and an anion, which is negatively charged. So the rules for this depends on where it's located. Like I said before, with the magnesium chloride, we needed to specify that magnesium was a non-transitional metal, or that was in the first two columns or groups. So that's why it says it's dependent on the location. And where is Dr. Henry? He said 5 minutes. It's been 30.
Yo, you skipped out. You gone.
Yeah. Gonna charge him. I'll request money on Venmo. So for monoatomic, it's not how you say it, but it's how I'm gonna say it. So you write the name of the formula of a cation. It's just the name of the element followed by the word ion. So if magnesium has a cation, which is Mg2+, is the cation it's going to form, it's nothing fancy. We just say it's a magnesium ion because that's the ion it likes to form. We know it's going to form a 2+. Then if we're naming an anion, we're just going to change the end of the word to IDE followed by the word ion. So if we get if like chlorine forms an ion, it's just going to be the chloride ion because it's going to form an anion. So we just tack on IDE to it. We call it good. Okay. So let's write the names of the Br negative and Ba2. Then the formulas for the potassium and fluoride ions. Okay, does anyone have an educated guess for the first one, the Br negative?
With bromide ion?
Yeah, so Br is for bromine. I'm going to tack on the IDE to denote that it's an ion. So we get bromide, and we just add the word ion. So it's the bromide ion. Okay, for Ba2, is this going to, or it tells you if it's going to form a cation or an anion based off the charge. So if it forms a cation, it's just going to be the name of it. So Ba is for barium. Yeah, barium. Then if we go back to the rules for cations, it's just the name followed by the word ion. So it's just going to be the barium ion. We don't need to add the words or we don't need to say cation or anion. That's kind of what the IDE tells us. So if we see an IDE, it's going to be an anion. If we don't, we just are going to assume it's a cation.
Wait, so the Br-1 was a bromine ion?
A bromide ion.
A bromide ion?
Yeah.
And the ide is indicating that it's a negative charge?
Yeah. So the ide is telling us that it's an anion, so a negative charge. Whereas if we just left it as bromine, we would have to assume it's a cation.
So if we say bromide, why do we even say ion then if ide already indicates that it's an anion?
Because bromide, right, can be taken as just Br2 because it could just be in the chemical.
Okay, so it's a bromide ion,
Yeah.
negative charge. All right.
Yeah, which is telling you that it's just a singular Br with a negative. If we don't have that on, we can assume, or we might assume that it's going to be Br2 because
Gotcha.
it's a diatomic.
All right. Thank you.
Yeah. Okay. Then. Okay. Then or Christina said, for the potassium ion, it's just going to be K plus. And for the fluoride ion, it's going to be Fl negative. So remember that fluorine, what do we use to represent fluorine? Is it Fl or something else?
It's just F.
Yeah, it's just F. So we need to remember that fluorine is just F. Aaron, this should be the chapter 6 PowerPoint. So this should cover chapter 6.
Quick question, Cole. Okay, I remember we had went over this already, but as far as like looking across on the groups, so group 7 is -1, group 6 is -2, group 5 is -3, group 4 is what?
Let me pull up a periodic table.
Only asking because like when we get questions like this.
Don't you mean group 17?
Sorry,
negative?
yes, group
Yeah.
17, group 16, group 15, group. Yes, Dr. Henry, hello.
Hello, Dr. Henry. Welcome.
Yeah, so group 14 though would be what charge? Is it -2 or is it +2?
Pull up your periodic table.
I did. Well, I mean, I have the paper one.
Here, I'll pull up mine. I'll share my screen. Sorry, it's working. I'm working on a grant that's due tomorrow, so.
You're early, Dr. Henry.
Hey, you
I'm early. I'm really
Yes.
early.
Yeah.
Okay, can you guys see my screen?
you
So
could
you were asking me about group.
Cole got it covered.
Which group were you talking about? 14?
Group 14, yes.
Well, group 14, think about where it's at. Group 14 is right here. And how far is it from being a noble gas?
4 places.
4 places. So if it's charged, it's going to be a -4, right? Or it's kind of in that middle, or it could be a +4. So what you're going to be looking at is, as I said, your S and your P, right? So that's going to make up your octet. If you count 1, 2, 3, 4, 5, 6, 7, 8. Okay. Carbon is 4 away from being a noble gas. So if it has 4, if it gets 4 electrons, it'll be just like, so it's going to have either a +4 charge or a -4 charge. If it's with the metal, it's going to be a -4 because the metals are positive. Carbon's negative in that case to balance out. Does that make sense?
I think so. I'm only asking because everything else to the right of it is always constantly the negative charges, right?
Yeah, this is kind of like your break point right here. Carbon is like your break point. And so everything on the other side is going to be positive, you know? Although you have these guys, your metalloids are kind of weird. They can act like a metal or they can act like a non-metal. And so depending on who they pair up with and what they're doing, their behavior might be different. Does that make sense?
Yeah.
Yeah. Don't overthink it. There's this nice little pattern and you'll get it. And once you start getting it, you're going to be like, okay, I got this. Okay, so we've talked about these guys. I should say Cole's talked about these guys over here, right? And so you're familiar with the charges associated with them. Brittany, fluorine is going to have what charge associated with it when it forms an ion?
Negative or +4, depending on who it's with, right?
-1 for
Fluorine.
Oh,
Fluorine.
fluorine.
Yeah.
Just -1.
-1. Oxygen,
-2.
-2.
nitrogen,
-3.
okay? And carbon is that one that's gonna flip-flop, right? Then we get to boron. We know that boron is gonna be,
+3.
okay, unless it's forming a covalent bond. Aluminum,
+3.
+3. And we know these guys here, magnesium,
+2.
sodium,
Sodium plus.
good. Okay, so those are simple, right? Those are, we got those down, not a problem. Now, remember that whole group that we always try to avoid? Those damn
The people in the
transitional
middle.
metals? The transitional metals, yeah, these guys. So these guys are kind of a hot mess, right? The reason why they're called transitional metals is because they have a lot of transitions, right? They could be +1, they could be +2, they could be +3, depending on who they're with and what they're doing. Their charge is going to be dependent on who they're pairing up with and also how we define it, okay? So, for instance, Fe3 plus, right? The way that we would describe this ion, we would call this guy, just for the name, so you guys know, it would be iron. If I could spell today, iron 3 ion. So, because the transitional metals have the ability to have multiple charges associated with them, we will often, not always, but often, we will have to tell what that ion is. So by us putting the Roman numeral there, we're saying that it has a 3+ charge. Okay. So are you guys familiar with your Roman numerals?
Yes.
Yes.
Okay, so let's see. So if I have Fe 4+, how would I name that?
Iron IVM.
Iron IV ion. Okay. Okay, so when they start pairing up with things, let's say we have Fe3+, and we're going to pair it up with, let's do fluorine, which we know fluorine is a minus. So how many fluorines will I need to balance out that Fe3+?
You'll need 3.
Okay. So the chemical formula would be Fe, F subscript 3. Okay. Now, the name of this guy is going to be iron 3 fluoride. You guys talk about the ides, fluoride, bromide.
A little bit.
Anytime that you you have a negatively charged ion that is monoatomic, you drop the ending and you put IDE. So like for instance, this is oxygen, but this is oxide. So this would be the oxide ion. This guy would be the fluoride ion. Cole, you gotta let me know what you've gone over.
Okay. Yeah, we briefly talked about the ide ion rule.
Wouldn't that 3 be like, is that a tri? Like it would be iron trifluoride?
Nope, you would call it iron 3 fluoride. So
You don't use those like Latin prefixes?
no, for ionic compounds, you're not going to use Latin prefixes. There will be some compounds that do that, but they're a special type of compounds. They're called complex ion. Those are different. And
What are the
we
ones?
won't get into that in this class. You'll get into that if you go into general chemistry. What was that, Nate?
I was just gonna say. So you said we don't do it for the ionic compounds.
For
We don't use
ionic compounds? Nope.
We use them on the. What is it called? What are the ones we use them on?
Complex ions. So,
Oh, but I mean,
Sure.
ones we're studying in this class.
so we'll be talking about, we'll use prefixes for nonmetals, or when we're talking about covalent bonds.
So covalent bonds are the ones where we'll use the Latin prefixes.
That's
And-
right.
For like the
And-
polyatomic and monoatomic ions, we just say 3 or 2 or whatever.
Yeah, we'll say, but we won't, they're not ion. Yeah, so for us, what we need to know is, right, because we know the negative ones, right, the nonmetals, we know that their charges based on where they're grouped at, right? But the metals are going to be given to us by that Roman numeral, right? This lets me know that this is a 3+ charge. Where if I was talking about iron 4 and I want iron 4 fluoride, then I would call it, it would be Fe, sorry, let me draw it, consistent, Fe, F4. So we need 4 of those. So then that will let me know immediately the charge on that iron, because there's only one iron. What is the charge on it?
On the iron.
On the iron in this compound?
But why do we?
4.
Doesn't that already tells us that there's 4 on the floor?
Exactly. Well, that's because I already told you that there was 4 on it, but you would be able to tell by what it's paired up with.
So
Okay.
like you're saying, if somebody said to us audibly iron 4 fluoride, we would write it FeF4. So this is like a way for us to audibly say what it's saying. Is that
Exactly. So
Okay.
you need to be able to write the name, because when you're asking for chemicals, or when you're looking for chemicals, it's going to give you the chemical name, or it may give you the chemical symbol, and you need to be able to know both. You understand?
okay? Yeah, I understand. A little bit.
A little bit.
Yeah.
Okay. Let me get my whiteboard. Okay. So let's say, for instance, we have this compound. Okay, what would be the name of this guy?
Will this be the copper? No.
Dr. Henry,
Copper 2 oxide?
copper with 1 Roman numeral,
Or
right?
is it copper 2 oxide?
So somebody says it's copper 1 oxide,
I'll say copper 4 oxide.
and you said it's copper 2 oxide, and then Nate says it's copper 4 oxide.
Yeah, Nate said that.
Was it? It wasn't Nate. Who was it? Nate, who you're taking credit for? Was that Edgar?
Yeah.
Okay, so these are the ones that you guys have told me, and let's see in the chat. Let's see, and then we have copper oxide. Well, copper oxide would be incorrect. Because we need the Roman numeral to let us know the charges. Now, there are certain ones, and we'll talk about the exceptions. There's always going to be exceptions because it's chemistry. If we don't have exceptions, then, you know. Okay, so let's see. So we have copper 1, copper 2, copper 4. So what is the charge on the oxygens?
2 minus.
It's 2 minus. How many oxygens do I have?
2.
2.
2.
Okay, now all together, what is the total charge right there?
4 minus.
4.
Minus 4, right?
-4.
And how many coppers do we have?
1.
1. So what has to be the charge on this to balance it out completely?
4.
Does that make sense?
Yeah.
That makes sense.
Okay, so again, this is just, it's that simple math. What plus what is going to equal, we want it, remember, always want to equal 0 when there's no charge associated. Okay,
I have a,
so
I have
the
a,
correct answer, what was that?
sorry, I have a question. I don't know if it's a dumb question, but how did you get 4 from subtracting 2 from 2? Or are you adding them?
Okay, so this is the minus, right? So these are the negative ions. So what is going to make it equal to 0?
Oh, okay. Somebody, thanks, Edgar. He spelled it out for me. I think I needed words.
Yeah. So minus 2, we add those together, that's -4, right? And so the charge on this guy has to be a plus. Does that make sense?
Yeah. I got it.
Okay, good. Okay. So do you guys want another one or do you got it?
One more?
One more? Well, that's good. Just one? Let's see. Okay, so what would be the name of this guy? And what is the charge on the tungsten?
Would it be tungsten 6 nitride?
Yeah.
Okay, so where did you get tungsten 6 from?
Just
Because
based,
nitrate has a -3, and you have to add to get them to balance.
what she said.
Okay. Good job. So does that make sense? Not too hard?
Dr. Henry, I have a question.
Yeah.
How do you know the charge for the ones in the middle?
By who they're paired up with, right? We know what nitrogen is. Nitrogen is always going to be what charge?
-3.
-3.
-3, right? So we have how many nitrogens?
2.
We have 2 of them. So then that means tungsten has to be, if it's completely balanced and it equals to 0, because remember, ionic compounds, we want it to equal 0. Tungsten has to be what charge?
Okay. 6.
6. So it has to be W6 plus, right?
Okay.
Okay. Questions, concerns, Cash, credit?
Money would sound good.
You said money would sound good. Money
Yeah.
always sounds good. Okay. So there is one I want to talk to you guys about, a special ion. So this guy here, this guy is Mercury 1. Mercury 1 is always diatomic. What does diatomic mean again?
2 atoms.
There's 2.
So the Mercury 1 ion is always going to be diatomic. There always have to be 2 here when you're talking about Mercury 1. Excuse me. And I love putting these on the test, right? So let me give you an example. If I have this guy, So what would be the name of this compound? Can you guys see that?
Yes.
Just in case.
Would it just be Mercury 1 chloride?
Mercury 2 chloride.
I thought the 2 is already a
Ooh,
1
ooh,
because
wait,
it
wait,
said
wait.
Mercury.
I love it. I love the argument. The correct answer is Mercury 1 chloride.
Oh,
Why would it be 1 this time?
Because here, what is the charge associated with it?
2.
So it would be written like this, but there's 2 of them, right?
Right.
And each of those are CLs, right? So there's 2 of these guys. 2 divided by 2 is what?
The 1.
1.
1.
But the thing is that this guy always has to be diatomic. Okay, Mercury 1 always has to be diatomic. So because Mercury 1 always has to be diatomic, it's going to be written like this. It really is, well, it's kind of like this. Oops. Screwing up here. There we go. Okay, it's really like this here. But because it's diatomic, it always has to be written like that. Does that make sense?
Right.
Okay, so let's say I had, we're doing Mercury, and it's just Mercury 1, not all Mercuries, just Mercury 1. So if I have Mercury 1 phosphide, what is the chemical formula of that going to look like?
Would that be Hg positive 3 with the 2 subscript on the bottom, P?
You said Hg. That's all I got was the Hg.
Yeah, with the 3 instead of the 2. P
So
or no?
would I put a 3 or would I put a 2?
I was about to say,
With
wouldn't
the-
it be
The
HG?
2 with the 3?
Okay, so now remember, it's always going to be H. It's always going to look like this, right? So, and then phosphide, what is the charge of phosphide?
3 minus.
3 minus. So for me, what works for me, because I'm a very, very visual person, and then, you know, I like to see pictures, right? So how can I fix this so that they balance each other out, right? I need enough of these to balance out enough of those. So how many of these do I need?
3 to make 6.
3.
I need 3. So Hg and it's 2 plus, and that's a 2 here. Okay, and then how many phosphides do I need?
You need 2.
And I need 2. Okay, so if I write it just like I see it, how many of these do I have?
3.
3.
So then I'll put my 2 here, and then my parentheses, 3. And then how many phosphides?
2.
2. Okay. Or I could be a bum and write it like this, because there's only one element there. Both of them would be acceptable. Yeah, that look.
What was the question again?
That threw me off. The parentheses with the
What is the chemical formula for Mercury 1 phosphide?
Okay.
And it's Mercury 1 because each Mercury still only has a charge of +1, right?
That is correct.
Okay, that makes sense.
Yeah, but you always have to remember Mercury 1 is diatomic.
I'm gonna need you to start this one over at the beginning.
Okay, that's fair. I'll start it over from the beginning, but let's try it with a different compound. And we'll go through it faster, right? Because you guys already get this. So if we have Mercury, Mercury 1, chloride. No, it's carbonide. Or carbide, sorry. Mercury 1 carbide.
Can you explain it extra slow, like I'm the dumbest person you ever met?
I can explain it extra slow. I don't know if I can explain it like you're the dumbest person I've ever met.
Just pretend. You just gotta pretend for me.
Okay, so Mercury 1 is a diatomic. That means that it's always going to have what, Nate? How many?
+2.
So it's always going to be +2, but how many of them are there going to be?
Oh, 2.
2, right?
Yeah.
So diatomic basically means that you have 2 of them, right? And they're always in 2. Okay, so this is my Mercury 1 ion. This is how you write it. This is the way it exists. It always exists as 2. What was that?
Why can you not have one Mercury?
Why can't you have Mercury 1 ion like this?
Yeah.
Because it's not stable.
Okay, so it just always has to be 2 so that it's stable?
Exactly. They come in pairs, you know? They come in pairs. It's like, you know, have you ever dated twins? They come in pairs.
Yeah, I dated twins a couple times.
So, okay. So now if we have Mercury 2, what is the charge on carbon? On the carbide ion?
Let me see.
It would be 4-.
Minus or 4+.
Damn it, Edgar. I know.
Or 4- for this case, so we can balance it.
That's right. It has to be 4- for this case because we want to balance it. Okay. So how many Mercury 1 ions do I need?
4.
Okay, so in this, would you need 4?
Do I need
Or
4?
like the parentheses 4? Like, so technically 8?
Do I need, okay, wait. Now look at the charge on it.
You need
Yeah,
2.
2.
I need 2.
That would give us 4+.
Oh, yeah, okay.
Balance it out.
Okay. So that's
Oh, I had
2 plus. Okay, so then my answer would be, you could write it as Hg. Oops, I forgot my 2. There. Hg2. And there's 2 of those. Or you could write it out as Hg4.
Yeah, I see what I did wrong. I mean, technically, it wasn't simplified, I guess, because I put Hg2 in parentheses 4 C2, but I added more than I needed.
And you don't want to do that because that is a different compound. And that's what you want to make sure that you're not doing, right?
Yeah, it hasn't clicked yet, but I'm just gonna sleep on it and hopefully it
So,
comes in the dream.
Brianna asked, is Mercury the only diatomic ion? Yes, Mercury 1 is the only diatomic ion. Mercury 2 isn't diatomic. Mercury 2, Hg, 2 plus, that guy isn't diatomic. Okay, so if I had Mercury 2 carbide, then I would just write Hg. Okay. Okay, is that good?
Is everything in that group diatomic?
No, Mercury only Mercury 1 is diatomic. Only Mercury 1. The only diatomic ion. Okay. Okay.
So that wouldn't be good, right?
What was that?
Hg2C, that's good.
This is for Mercury 2. So this guy would be I could spell 2 carbide. So this is Mercury 2 carbide. This here is Mercury 1 carbide.
But your Mercury 2 carbide, that's balanced. Like that's correct how it is.
Yeah, because it has a 2 plus, right? So there's 2 plus, 2 plus. That means +4 total. Carbide is 4
Okay,
minus.
okay, I see. Yeah.
Yeah. Now, don't overthink it. It's just, remember, it's just that simple math, right? You just want to try to balance it so that it equals 0 at the end. Okay? Are you with me so far? Okay, so now these are ionic compounds, right? So these are very simple because they're all monoatomic compounds. So I'm going to start introducing to you polyatomic ions, right? And we're going to play with those a little bit too, okay? So how many of you guys have your polyatomic ion sheet? I would strongly recommend that you print it out. It either came in your packet or it's in your resources. Looks like this.
Oh, okay.
Okay, so this is your polyatomic ion sheet. I am probably the only professor that I know that don't require you to memorize it, right? The reason why I don't require you to memorize it because I'm going to have you use it so damn often that you're going to put in your head regardless. Okay, so let's talk about some of your polyatomic ions. Can I clear this screen? Are you guys feeling comfortable with this so far? Don't worry about it. You're going to get a lot of practice. Ammonium. Ammonium is NH4+. Okay, now you guys have been drawing this already. You guys drew the images for it already, right? Can you guys do that?
The Lewis structure?
Yeah, you guys did the Lewis structure for it. Okay, so this guy has a single plus charge. So if I have ammonium oxide, what is that guy going to look like?
NH4,2O.
So how many ammoniums will I need to buy? What is the charge on oxide?
2 minus.
-2, -2.
-2. Okay, and so how many ammoniums will I need to balance it out?
2.
Okay, so I'm going to need 2 of those, right? So the way I would do that is I'll put them in parentheses. Put the subscript 2. And we only have 1 oxide. Piece of cake.
What's the point of moving the charge to the first? I guess I'm just not understanding, like, why are we moving the -2 charge to a +2 charge on the first atom or compound?
I don't understand what you're asking me.
Yeah, I mean,
So
I know what you're asking me. So you're looking at that positive and negative. Think of it as like it's what you have to cancel out for it to be 0 or to be balanced. And that's how it ended up being on the bottom. So it's not that he's moving that -2. It's just it representing that it canceled.
adding charges to the first compound to cancel out the negative charges on the second compound?
this here, ammonium, this is a compound. This is an ion, right? It's a polyatomic ion. In other words, it's covalently bonded and it has an electron removed from it already.
Right.
Okay. So this guy is one polyatomic ion. It is an ion. Okay. So this guy, oxide, is also an ion. It has a -2 charge. Now, when we talk about ionic compounds, we want them to balance out in charges, right? If this guy has a +1 charge and this guy has a -2 charge, how many of these guys do I need to balance this guy out?
Well, what is balanced considered?
Balance means you have a total of a 0 charge.
Like the formal electron stuff that we were dealing with?
Yeah, because this represents electrons, right? So this guy is missing an electron. This guy has 2 extra electrons.
So,
So we want the charges on them to balance out. Remember, opposites are going to attract. You need to balance out your charges.
right.
So when you put these guys together, they're going to form a compound that balance each other out. So you put ammonium and you put oxide in a bowl together, they're going to fight each other and then they're going to pair up. And you're going to get how many ammonium to balance out that one oxide?
2.
You're going to get 2, right? And so this is how you write that compound. Does that make sense, Nate?
Yeah, that helped.
Okay. So you guys have to remember, it's all about, remember when I talked to you about, having that person that was opposite of you, right, in high school? The bad boy and you're the good girl, right? Now, if you guys are even, you balance each other out perfectly. If you're not even, right, he is really, really bad, he's going to need 2 or 3 good girls to balance him out. Okay? So like, for instance, oxygen is pretty bad, -2. And ammonium is +1. So we need 2 ammoniums to balance out that oxygen, or that oxide. Does that make sense?
That makes sense.
So you're not ignoring the bottom number, but you're recognizing that these guys are moving together, right? They're a compound, right? And so that's why they're called polyatomic. Poly means what?
Multiple?
Multiple. Atomic?
Atoms.
Atoms, right? Multiple atoms. So we're polyatomic ions. Okay, so let me give you another one.
Bromate.
I want to give you sulfate first, because we're going to talk a little bit about sulfate, then sulfite. Okay. So sulfate, anytime that you see the ATE at the end, that means it has oxygens, right? It's, in this case, it's sulfur and oxygen, right? But it's SO4 2-. Okay. Yes, the bottom means that I have 4 oxygens, right? So that number, the subscript represents the number that I have. The numbers down here represents the number that I have, right? So for instance, in ammonium, ammonium has 4 hydrogens in it, right? But when I put ammonium with oxide, I need 2 ammoniums, right? So that means I have 2 of these guys to balance out that oxygen, okay? So if I have, let's see, aluminum, sulfate, aluminum sulfate. So aluminum, what is the charge on aluminum?
3+.
Aluminum is 3+, so it's Al 3+. We know that sulfate is 2-. Okay, so how many sulfates will I need to balance out my aluminum?
3 and with 2 aluminums.
So I'll need 3 sulfates. And you said 2 aluminums.
Yes.
Okay, simple. Sal, you're not saying anything.
Yeah, there's some construction going on in my house and it's kind of loud. That's why my mic's cut off.
Okay.
But I'm kind of getting it. It's like chemical equations, but in a weird way.
Yep.
Everything has to be balanced out.
That's right. And you notice, again, I will stress this. There's not saying 2 aluminum, 3 sulfate, right? We don't do that, right? We just put what it is because we know the charges associated with it. Okay. Does that make sense?
Yeah.
Okay. So let me talk to you a little bit more about some more polyatomic ions, and then we'll start playing more with this. Okay, sulfite. Sulfite is SO3 2 minus. Hypo sulfite is SO2 2 minus. And per sulfate is SO5 2 minus. Okay. So if your kid ate a whole bunch of candy, what happens?
Bounce
Angie?
off the walls.
They bounce off the walls, right? They're hyper, right? Per. Okay. So when we have an extra oxygen, we call it per sulfate. Notice the ATE is still there. And per for hyper. Okay. So and then we have sulfate. Sulfite has 1 less oxygen than the sulfate. Hypothermia, that means what?
Low temperature.
Low temperature.
Low temperature. So low, below, right? So if I lose 1 more oxygen, it's hyposulfite. Does that make sense? Yes, no, maybe?
Yes.
Yeah.
Okay. So if I have bromate, what is the chemical formula for bromate? Angie, chemical formula for bromate. The bromate ion. Are you not talking to me? I
Can
see
she
the
phone
top
a
of your head.
friend?
What was that?
So can she phone a friend?
Yes, I'm here. I'm looking for.
That's correct.
Is it -1?
Yep, it's a -1 charge. So it's BrO3 with a -1 charge. Okay, so what does per bromate look like?
BrO4.
Okay.
Negative.
What does hypoperbromite look like?
So that'd be BrO2.
Would it be a BrO2?
Would it just be BrO?
Hypo,
Negative.
It would be
Negative.
BrO. And then bromite would look like what? I did them out of order on purpose, so I can get Brittany all mixed up.
BrO2 minus.
There you go. Make sense?
yeah.
Oh wait, I have a question.
Yes.
So Carter, please wait. So is it just okay? Yeah, because you did put them out of order, and yeah, my brain was kind of going in that way. But so when whatever you start, because how bromate starts at O3. So depending on what level you step up or down, no matter what, that's how you minus it. Is that how that goes?
Yeah.
Okay.
So the 8, you need to know what the 8 is starting at, right? So for bromate, it starts at O3. For sulfate, it starts at O4. Okay. And if you notice, what is the charge on bromide? What would be the charge on Br? Helen.
-1.
Negative 1.
Good job. Okay. Now Br is -1. Bromide, right? Or bromite. Hypobromite, -1. Hypobromate, -1. It has the same charge. Okay. Now, for the most part, they obey that rule. There's one exception. Okay. So we know that sulfur, what is the charge on sulfur?
O4.
Sulfur?
2 minus.
-2.
-2, right? So sulfide was going to be a -2. Right? Sulfite, hyposulfite, -2. Sulfite, -2. Okay? Okay. Phosphide. What's the charge on phosphide?
What did you say, Doctor? Did you say something else?
No, I said, what is the charge on phosphide? Sorry, I'm a little away from my
-3.
-3. Okay. So we would assume that phosphate, which is going to be PO4. What's going to be the charge associated with it?
The -3.
-3.
-3. Okay. So per phosphate, it's going to be what?
PO5 3 minus.
Okay. Okay. Phosphite.
PO3 3 minus.
Hypophosphite.
PO2 3 minus.
Okay. So are you guys ready for your exception?
Yes.
So can anybody guess who the exception is? Or which element is always going to give us an exception? Every once in a while, I'll throw us a blue moon.
Is it hydrogen?
Nope.
It got to be mercury again, huh?
Nope.
Carbon.
Nope.
Iodine?
Nitrogen.
Oh.
Nitrogen. Okay.
Nitrogen is the first.
So NO3 minus. Okay. So normally nitrogen would be 3 minus, but nitrate is NO3 minus, just a single minus. Pernitrate would be
NO4 minus.
nitrite.
NO2 minus.
Okay. And hyponitrite.
NO minus.
No, no, no. That's correct. Okay. Piece of cake?
Oh yeah.
And so does it mean that whenever they're hyper, they're positive?
Can you repeat that, please?
So whenever they are hyper, like for example, hypernitrite, would this be positive?
No, it doesn't mean that it's positive. You're not changing the charge. The charge always stays the same. You notice negative, a -1, a -1, a -1, a -1. Charge is always going to be the same. The only thing that it means is that you're changing the number of oxygens. Per nitrate, you have 4 oxygens. Nitrate, you have 3 oxygens.
Three.
Nitrite, you have 2 oxygens.
Yeah.
Hyponitrite, you have 1 oxygen. Do you see how it drops?
Yes.
Okay.
So where would the hyper fit into this one?
Per, we don't use, so because we use hyper for other things, some
Okay.
chemists said, oh, I'm not going to use hyper, I'm just going to use per, right? Instead of using hyper, they use per, PER.
Okay.
Stand for hyper.
Doctor,
Okay.
I got an appointment, so I got to run. But do we have a lab today?
Your lab is actually going to be doing nomenclature. You're going to get started on your nomenclature.
Wait, I didn't hear you. I'm sorry. Can you say that again?
Your lab is actually nomenclature.
Nomenclature?
Nomenclature. That's going to be your lab. Yep.
We don't have
So
a
you-
lab.
So it's a dry lab. It's a piece of paper that you write the names on.
Okay, that's the assignment that went up on the site or whatever.
Yeah, it should be up already, but I have to check. It may not be.
Okay. And yeah, all right. I gotta head out. I got an appointment. Thank you. Thank you.
Okay, you're welcome. Okay. Questions, concerns, Cash? Now, I'm going to say this, right? Don't get intimidated. It's real simple and it'll start clicking. But the way it's going to click is by you doing the homework and by you doing the lab and everything. And I'm going to give you like 1,000 problems. That's the only way it's going to click. And you're going to hate me. Isn't it right, Cole? Did he leave?
What was that, Dr. Hunter?
I said, and they're going to hate me for giving them 1,000 problems.
Yes.
Problems to
Yeah.
get wrong. But the way you learn, you know, okay, let me be honest. I never really learned anything when I got things right. I learned things when I got things wrong, right? So like touching the stove. It took me touching the stove, you know, my mom always said, don't touch the stove, right? Did you learn from it?
No.
Anybody? Your mom says, don't touch the stove. Did you obey or did you have to touch the stove to prove to yourself?
I obeyed.
You obeyed. I didn't.
We
I
all
was the
learned
first one.
thing.
Don't play with the iron. Well, guess who played with the iron? I got a nice little tattoo on my arm because of it.
Dr. Henry, I know you already got off the screen, but just for my own notes. So I I'm trying to remember so I don't get thrown off with the whole 8-ite thing. So hypoite will always be down 2. Ite
Mhm.
will always be down 1. 8 will just be whatever the same thing it is.
Yeah.
And then para or perna
Per.
will be +1.
That's right.
Okay.
Yeah, I was told not to do that too, Michael. I had to learn the hard way. But the way that you learn is by keep trying, and look at it. It'll start clicking because it really is just adding and subtracting. A lot of it is just going to be adding and subtracting. Remember that you always want it to equal 0 and adding and subtracting. No, the 8 is the root one, right? 8 basically means that there's an oxygen in it. So anytime that you use ATE, there has to be an oxygen in it. There's a couple of cases. And instead, in those cases, they actually use sulfur instead of oxygen. Or they'll use, cyanate. So they'll use, there's like 2 exceptions that are out there. And they're actually, I believe I have both of those exceptions on your polyatomic ion table if you guys take a look. Because there is a thiocyanate. Okay. Okay. Questions, concerns, Cash, credit.